Before we begin, we must remember what each tile represents. The large blue square represents positive x squared, the long green bar represents positive x, and the small yellow square represents positive 1. When we turn them over to its red side, it represents its negative component. Negative x squared for the large red square, the long red bar negative x, and the small red square is negative 1. When we do not have color tiles to use, we can still demonstrate using algebra tiles. We simply shade when we're referring to positive numbers and leave the blocks unshaded when looking at negative numbers. Let's begin. In example 1, we will multiply x plus 4 times 2x plus 1. When using algebra tiles, we start by drawing a t-chart. Along one side of the chart, we fill in the factors x plus 4 using algebra tiles, x, the long green bar, and 4 single units, giving us x plus 4. Across the top, for 2x plus 1, we draw 2 green bars and a single unit. Our product is the result that occurs inside of our chart. When we multiply the terms outside, x times x gives me x squared, x times x, x squared, x times 1, 1x. And we do this for the entire chart until there's no terms or blocks left. 1 times x, x, 1 times x, x, and 1 times 1, which is 1. The bottom 3 lines are exactly the same as the line we just completed, leaving us x, x, and positive 1 all the way down. The solution are the tiles that remain inside this chart. As we can see here, we have 2x squared blocks, or 2x squared. We have 9 long green bars, or positive 9x, and 4 single units, which represents positive 4, giving us a final solution of 2x squared plus 9x plus 4. Let's try a second example, only this time we'll include a negative number. Once again, we'll draw our t-chart. On the left-hand side, we draw x plus 2, and across the top, we want to draw 3x minus 2. 3x, 1, 2, 3x bars. Now careful, with the negative, remember we want to draw the red bars. Multiplying, on the inside, we get x squared, a second x squared, and a third x squared. For the last two, just pay extra attention when you're working with negative signs. We have a positive times a negative, which gives us negative x. Positive x times negative 1, another negative x. Continuing down the line, positive 1 times x, positive x, positive x, positive x. And at the end, we have positive 1 times negative 1, which gives us negative 1 for both of these. The last line is exactly the same as the third. So we get x, 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 and 2 negatives. In our solution in this case, we see that we have 3x squared bars, or 3x squared. When it comes to the x bars, though, we notice that we have 6 positive x's, and we have 2 negative x's over here. When you have positive and negative of the same term, they're referred to as zero pairs and in fact can be canceled. So we can cancel out this negative x and a positive x. This negative x and this positive x is another zero pair. We are then left with 4 positive x, and we write plus 4x. Our final 4 blocks here gives us negative 4, for a final solution of 3x squared plus 4x minus 4.